Hi everyone. In this session we are going to discuss about the chemical thermodynamic. Before we begin, let's look at example of some common chemical reaction like the burning of coal. When coal is burned, the chemical energy stored in the molecule is released as heat or thermal energy. Another example is that of being of fuel in a car engine. When the fuel burns in an engine, it converts the chemical energy to mechanical energy, propelling the car to move along the road. In both the example, chemical energy, that is the energy stored in the bonds of atoms and molecules, is converted to other forms of energy. Thus, various forms of energy are interrelated, and under certain conditions these may transport from one form to the another form. At the end of this session, you will be able to define thermodynamics, explain thermodynamic process, term used in thermodynamics, system, surrounding and universe, types of system, open system, closed system, isolated system, properties of system, state function, path function, extensive property, intensive property, and last exercise. Let's see the definition of thermodynamic. The branch of science which deals with the quantitative relationship between heat and other forms of energies is known as thermodynamics. The word of the thermodynamics is come from Greek. Thermo means heat and dynamics means flow or motion, means heat in motion, and it was coined by James Jewell in the early 19th century. Let's see the terms used in thermodynamics. There are three main terms that we use in thermodynamic, namely system, surrounding, universe. First, system. A part of the universe under thermodynamic investigation is called the system. Second, all other parts of the universe outside the system, such as a cylinder, room and others, are surrounding. Third, the universe is made up of system plus surroundings. Thermodynamic system. Thermodynamical system classified into three categories, namely open system, closed system, isolated system. Let's see one by one. Open system. System is said to be open. It can exchange both energy and matter with its surrounding is called as the open system. For example, coffee becomes cold when left open for some time in a container as a result of exchange of energy with the surrounding. At the same time, some amount of coffee escapes from the cup as a vapor. This is because of exchange of matter with the surrounding. Hence, this is an example of an open thermodynamic system. Next, that is closed system. A system which permits the exchange of energy but not the exchange of matter across the boundary with its surrounding is called a closed system. For example, if coffee is kept in a closed cup, it takes some time to cool down. This indicates that energy is exchanged with the surrounding. However, as a vapor cannot escape from the cup, no exchange of matter is possible. Hence, this stands as an example for a closed thermodynamic system. Third, isolated system. A system that can exchange neither energy nor matter with its surrounding is called an isolated system. For example, the coffee kept in a thermos flask remain hot and the vapor also does not escape out. This is because neither matter nor energy can be exchanged with the surrounding. Hence, this is an example of an isolated thermodynamic system. State function. The property which depend on the state of a system and independent of a path followed to attain it is called as a state function. Few examples like temperature, pressure, energy, volume, mass. Path function. The properties which depend on the path are called path function. For example, work and heat. Let's see the properties of system. There are two properties of the system, namely extensive property and intensive property. Extensive property, a property which depends on the amount of matter present in a system, is called an extensive property. For example, mass, volume, internal energy, heat, capacity, number of molecules. Intensive property, a property which is independent of the amount of matter in a system, is called intensive property. For example, pressure, temperature, surface tension, viscosity, melting point, boiling point, specific heat. Let's see few questions. First one, a well-stoppered thermos flask contains some ice cube. This is an example of, option is closed system, open system, isolated system, non-thermodynamic system. The correct answer is isolated system. Second one, in thermodynamics, a closed system refers to a system that, option is, first, does not interact with its surrounding, B, allow heat transfer but not mass transfer with its surrounding, allows mass transfer but not heat transfer with its surrounding, D, does not allow any form of energy transfer with its surrounding. Correct answer is allows heat transfer but not mass transfer with its surrounding. Next question, which of the following is an extensive property in thermodynamics? Option is temperature, density, pressure, heat capacity. The correct answer is density. Next one, choose which of the following statements are true about state function. Option is enthalpy is the example of state function. Second, all state function are also path function. Third, the path taken from reactant to product is irrelevant. D1, state function always have a positive delta H. The correct answer is D, state function always have a positive delta H. Next, which of the following is an of example of path function? Option is pressure, enthalpy, work and volume. The correct answer is work. Which of the following is an intensive property in thermodynamics? Option is volume, mass, energy, melting point. The answer is melting point.